right about. Hi everybody. So I'll show you a few more images of disks today. So I'm kind of at the workshop to try to understand whether I could apply YT to analyzing my phantom simulations, which phantom's not natively supported, but there is SPH, like YT can handle SPH data. So hopefully I come away with something. So some common analyses that we do when we are working with protoplanetary disks, primarily when I work with gravitationally unstable planetary disks, so we have a lot of features. We have clumps, we have spirals. We want to analyze, for example, velocity dispersions in those. We want to delimit edges of disks, and so we want to do line of sight, a sort of density estimation, which I saw that YT handles quite easily. Want to get the column densities in the midplane. Also clump identification, which that was the first time that I tried to use YT was, back at some point I was talking to Britton about, trying to use YT's clump finding routine, but in the end just didn't work out. So I had to do it in different ways, or, radial velocity transport. So these are some of the common things we do, but personally for myself, maybe more experience, phantom users will have much more refined workflows, but it's a little bit convoluted. I'll go in a little bit more detail in the next slide, but currently our options are either using the Splash package, which was written by Daniel Price, who's Phantom's author. It's fine. It's good. It's well featured. There's a bit of a learning curve, and not everything's possible. Or we can export the data directly to ASCII or HDF5, but I've not figured that out yet. And that shouldn't be overlapping there, but we can just export the SPH data into ASCII and either do the usual phantom analysis, or actually, if anybody knows VisPy, it's a fantastic package. It handles like massive particle counts that you can kind of fly around in real time. It renders it really well on this MacBook. And so just to go in a little bit more detail about the workflows that I currently have as my options, either, as I said, use package, but use the Splash package, but there's a learning curve, and there's a GUI that's associated with it, especially when you're connecting over SSH. That's really, really slow when you're like zooming in and dragging and dropping boxes and things. We can use this SAS and Python package that's made for Phantom, but it's pretty poorly featured unless I've just really not figured out how to use it. But yeah, we can do the exports, and the bottom two exports just feel quite convoluted. So yeah, what I'm saying is it'd be nice to have some more out-of-the-box support, or if I understood how to use phantom data in YT, I think I could call a lot of these. And just to illustrate the analyses that I showed you 2 slides ago, we'll revisit them. This is what it basically looks like when I'm trying to. It's all bespoke essentially. Yeah, so the workflows are not easy. And from what I've been hearing today is that a lot of this could be just made, very, very, very quick and simple. And I think we could do some really interesting work if I personally had more experience, or had YT available. So my aims for the workshop are to understand the scope of YT, to try to easily load my phantom data into it, and then just have fun. Also, the Phantom SPH, they have a lot of really cool emojis, so I wanted to include this one. And I also brought a sample data set, which I didn't upload beforehand, but this is it. Essentially, it's a very simple disk with 10 species of dust and some gas, 3 planets, and 2 stars. We were talking about off-axis disks today. That's not off-axis. I just rotated a little bit, so it's a little bit more visually pleasing. But yeah, there's a binary format available. Phantom is open source, so the read and write routines are available to look at. I've not personally yet, but I also have an ASCII format with me. So yeah, thanks very much. And
thank you, Adam. We can't get you on the path to getting that loaded this week.
That would be cool. I'd be really, really happy to start trying these things on my own data. Yeah.
Lovely. Thank you. Finally, we have Jen. Great. All right.